So I wanted to discuss the basics of using WebSockets. I've used them for many years now, and I believe that they're a good way to be able to have real-time communication between like a client and a server, or between like two people, really. When I was young and I first heard of WebSockets, I had first remembered them for video games. I remember trying to look into what netcode was, because that's really just kind of an obfuscated term in the gaming industry for how you can basically play a game with someone else in multiplayer. And when I was looking into the deeper aspects of how those things worked, I came across one protocol called WebSockets, which I even had heard of before that, to be honest, but it was never something that I had seeked out. It wasn't something that I fully directly understood. And at the end of the day, a lot of the times when I needed to do communication that was like back and forth, normally I would just think of doing some sort of ping-ponging type of concept with an API. So when I first decided to start working with WebSockets was when I wanted to make a graphical UI for a CLI that I had made. I was working for an MSP at the time, and I had built a CLI that can kind of do some of the basic ins and outs that we would normally do for many companies. But really fast, and it was able to do like multiple things at once. It was pretty good and fleshed out as far as the CLI that I had built, but I wanted to have it integrated with Outlook or with a web application. I wanted it to kind of be something where a person didn't have to directly use the CLI, but they could do like commands that would basically be applied on the CLI, and then they can see kind of the output that would have normally been seen on the CLI or in your terminal or your PowerShell or whatever, but at least in a front-end graphical UI. And so that's what kind of got me into deciding to do WebSocket. So for the rest of this video, I'm going to show you how to set up your own WebSocket using Flask, in particular from Python. But I've done this in numerous different languages because the concept of socket.io or WebSockets are usually available in pretty much any modern language, so you really don't need to worry. Like, I've done this with Blazor, I've done this with React, I've done it with Svelte, I've done it with Vue as well, I've done it with Django as well. I've done this with a lot of different web frameworks, so to speak. So even if we go to socket.io and look at the basic information here, we can see that it's available in pretty much anything. So the first thing to do is install Python, right? After you have Python installed, you're gonna wanna install Flask, and you'll wanna install Flask socket.io. And if you do wanna follow along here, I do have a repo called Basic Socket. It is in the link in the description below. You could just clone this, and this should have everything involved with it. So before I actually get into how it works and everything like that, we're gonna go ahead and just run it, right, by using Python app.py, and then you should be on your development server. I'm gonna control click on this so I can bring it up, and boom, there we go. We have socket connected and real-time updates example. I haven't messed with this in a bit, but this was essentially something that I had worked on just as an example to show that how easy it is to do WebSocket connections. Let me actually click on start updates and see what happens here. This is a good example of what's going on. Once I hit start updates, it basically will constantly send out information in this socket emit function. The socket emit function is basically just using this call here called server update, and it basically just has the time to it. That's about it. The way the whole file works in total is that you have Flask imported and the actual Flask socket module imported, along with time, just for our example of actually constantly updating the time, and showing threading here, because most of the time in your sockets, you are most likely going to have threads for background processes in particular, just in case of whatever you're doing. But I also want to be clear, you also don't have to use threading in particular. You can also do something called like import multi-processing and use that instead. It just kind of depends on what you want to do to separate out whatever background process you want from the actual web server. And there's actually numerous other ways to do this. This example is just using threading. Then we set up our app variable with the Flask class, and then from that, once this is now a Flask instance, we now wrap that into a socket.io instance. So therefore we can be able to have our normal app routes that we normally do with API calls, but then for socket.io, it can use our Flask instance to be able to do calls like connect to the client and have that persistent connection, or any other calls that I make up. The other important side of this is going to be the front end side of this. When you're using plain JavaScript, you can normally just import it with a script tag. But if you're using something else, like, in Blazor, you may have to import in their package to be able to then make it work properly. If you're using something like React, Vue, or Svelte, it's one of those same things where you're going to have to most likely use npm install with whatever like socket IO package that's available for it to work in ES6 properly. But once it's actually added to your project, normally it's going to be the same throughout all. What I do here is that I'll create a socket variable to immediately connect to the WebSocket server. And once I have that connection here, then I can be able to use it all up and down my code. Normally, if I was doing something basic like this, it's fine to have a var connection like this. You may have a let if you're using just pure JavaScript directly, because you'll need to use it everywhere. But normally, if you're doing something with React or whatever, you'll probably have a reusable component that you can be able to use throughout your code. There are two functions that you can kind of see here from just looking through both the backend and front end that are used here. There is the emit function and there is the on function. The on function is basically waiting for this event to fire. When you do fire this by emitting, it will do what you asked on whatever side, right? So for example, on connect here, when I do on connect, it will run this function of handle connect, which will say client connected. And then from there, it will then do server update, where it will say data socket connected, right? Now, emitting server data update has an effect on the front end. Now, doing an emit on the back end will have an effect on the front end if you're looking for it. So when you say socket on server update in the JavaScript on the front end side, it's looking for that emit. Now that we see what this emit is, it's going to put that over to the screen. So when we were looking here, it first said socket connected, because that's essentially what we had in the data that we passed through. And as you can see in the function message argument here, we basically pass in that data that we get from right here over into the text content so that you can see it on the screen. Once we hit the start updates button, we have an event listener in JavaScript, just some basic JavaScript that will do the socket emit, right? Since this is on the front end, it's going to emit that information on the back end, and we have something for that that's waiting on the back end called start update. It's going to use that thread that we were talking about before to make the background process of basically constantly sending the time. This specifically doing the while statement or the while loop allows you to constantly send back or constantly emit information, which is one out of many ways to be able to constantly ping back information, so that for this example, we're getting back the time every single second. So I changed some things so I can show you guys kind of a different example, one that I've actually used before personally. I actually like this a lot. What we've done here is now added in a different script or process altogether. And what's helpful about this is that this allows you to not have to actually write things directly fully in Python. Let's say you had a script or some other thing that's written in a completely different language or whatever, right? But you're able to run it at least from the command line at any, like on Windows or whatever your device is, right? With this, you can basically still be able to run it in Python and it get piped out to the front end. And that's basically the changes we've done here. I've imported in the subprocess module that comes baked into the standard library of Python. And with that, it has a couple different things that you can do. One of which that I find awesome is Popin. It basically allows you to run things that you would normally run at the command line right in Python. So I basically started up CMD and ran the trace script that I created here, which is just a simple for loop that allows you to do a trace cert against about 15 normal sites, Google, Amazon, Facebook, all of those things. And as it's actually going through the trace cert, it's going to then pipe this information back into the WebSocket. You have this std out pipe and std out error, so that therefore you can actually grab the information that would normally be strung to the std out or std error that you would normally see on the screen when you're in your PowerShell or CMD or Bash terminal or whatever. and then we just buffer the size by 1. In particular, I always have found that helpful. And then this is the line that I usually use in most of my code. After you actually create out your process variable, you can then use a for loop to basically get every single line, strip it down and parse it down that you need to correctly, and then send that into your socket. And that's what you'll normally see. And if you look at the while statement comparatively to the for loop, they're essentially the same, right? Inside of the loop, you have constant information that you need to send, and inside of that loop, you can constantly emit back that information so that it shows up on the front end. Now on the front end, I actually did some small changes too. I just did some graphical changes to make it look like a terminal. What I do is I just create a little pre-element here, and that usually makes your whole box or window kind of look like a terminal all on its own. So now if I click on start updates, it's going to run that tracer script that I had created and go through all the websites that I wanted to actually trace the IP addresses for. So that last example was really good for showing how you could be able to run any script with this, but when you do it the way at least I was just showing you, it would basically be broadcasted everywhere, which isn't good. So for example, if I decide I'm going to go ahead and run this and hit start updates, as you notice, it also ran on this second page here all on its own. And again, that's because we're technically broadcasting everywhere. If I go into the app here and I look at the parameters for emit and the on connect and everything like that, there's nothing that basically separates that information out from any other client who would be connected to this WebSocket server. And so we're going to basically change it so that now the WebSocket will have what's called rooms, so that therefore when I try to connect and keep a connection with this, that only my room has its own information and therefore won't be broadcasted to everyone who's connected to the WebSocket server. Now that we have this going again, we'll refresh this page. Notice it says joined room with this information here, and then this second one here comes with a completely different joined room ID string. I'm gonna go ahead and hit start updates on one of these, and if you notice now, only this room is going to get back information for this specific tracer. If we go into the backend here and look at the updates, you'll see that I've also imported UUID. It's just a way to basically create a universal identifiable string. This random generated string can be used as the room ID. If we look at the background thread function that we had from before, we'll notice that we now have this extra argument called room, and we pipe in the room ID that were generated. In fact, in the function itself, it actually requires that we have a room ID added now for the background process. Now, if we go down to the background process, which gets started up on start updates, we'll see that we now have an argument for room ID, which we pass through so that that function will now have something. And we get this room ID from a UUID to basically create out a string, and then we can use that to join the room. Once we join the room with this ID string, we're then able to use this same room anywhere else throughout the actual calls that it uses. So when it's able to then connect and do anything, it's going to constantly have that room ID with it. And there's other ways you can do this in particular. For example, if you were using something like sessioning, like Flash sessions, you could basically map the session with the room as well. There's a lot that you could do with rooms, but this is how you would isolate out your specific WebSocket connection information per each person. So I hope the video was cool and interesting to you. If you liked the video, please leave a thumbs up and please subscribe. If you had any comments, concerns, or questions, please feel free to leave them in the comments below, as I love to interact with you guys. And other than that, I hope the rest of your day goes well. Peace, everyone.